All right, ladies and gentlemen, how are we doing today?
Hi, YouTube.
Why do you always laugh at that? It's not fun.
Hey, we're recording now. Okay. I guess I should turn my computer on.
I really don't.
Yeah, you're right.
Okay.
I see how.
About the recording or about math in general?
Yes.
That's my life. That is my life. All right. Let's get that out of the way. All right, so as I was just explaining before I started the recording, sorry everybody, their factoring depends on how many terms that they have. Now, what does it say right after the title of the lesson? Factoring special products, and what does it say right after that? Always see if you can factor out a GCF first. So here's what I'm going to do. At the beginning of this flow chart that I have here on the board, which you can't see at home, sorry. Sorry, YouTube fans. What you have to do is always check for a GCF first. Right? Check for a GCF. Now, do any of the, are they all going to have a GCF? No, right? We've had many problems where there's no GCF. You just have to jump straight to something else. Okay? So you check for a GCF first. Are they all going to have a GCF? No. But if you can pull one out, then do something else with it. Then it breaks down by number of terms. We don't know yet what to do with something with 2 terms, other than factor by GCF. We know what to do if it's 3 terms. And if it's not either of these methods, then it's just not factorable. We know something to do with 4 terms. You factor by grouping. If it doesn't factor by grouping, then it's just not factorable. Okay? Now, let's refresh our memories. Again, I was saying before I started the video, if we see these directions in our homework tonight, you're going to ignore those. Okay, you're going to ignore those. We're just going to factor like normal. Okay, we're going to factor like normal. Okay? Go ahead and factor that, please. Come on, guys, figure it out. What are you going to find the factors of? What do they have to add to get to? Okay. Is this an easy type or hard type?
Easy.
Okay. I should have checked, was there any GCF at the very beginning? Was there any GCF? Do these three terms have anything in common? No. Other than a 1, thank you. Okay, so what number am I going to find the factors of again? 4, right? Because of this right here, right? That 4 tells us, okay, I need to make this list. 1 times 4, 2 times 2. Which set of factors worked? 2 and 2, right? So this turns into x plus 2, x plus 2. Is there another way to write that? Is there another way to write that? You're close. I would write it like this. Don't distribute in, but I would write it like that. Oh, wait, whoa, I'm sorry. I'm sorry. Whoa, it's Monday. It's Monday, okay? It's Monday.
It is Tuesday.
You played yourself.
See, I'm the one that always does that.
It's x plus 2 squared. Now, whenever something's written twice, you write it could be that squared. Now, look at the title of today's lesson. Factoring special products. You guys remember when we did that lesson back in chapter 7 where there were those special things? Right, that.
It's Monday.
It's Monday. It's Monday. Good thing it's Friday.
I'm not coming to school anymore.
Me neither. Okay, so remember back in chapter 7 when we had those special products, ones where we could FOIL like normal, but they just came out as special things? This is the exact same thing. Okay, this is the exact same thing, but now, again, in chapter 8, we're working backward. We're starting with the special product, and we're factoring it down, okay? What makes this so special? Okay, what makes this so special is that it comes out to x plus 2 raised to the second power, x plus 2 squared. If you were to give it to me like this on an answer blank, I would be completely fine with it. So just like, we could have FOILed the exact same way that we could have done before. We can factor the exact same way that we could have done it before. But here's what makes it special. We all see that this ending number is a 4, right? That has to be what's called a perfect square. 4, 9, 16, 25, 36, 64, I forgot 49, sorry. 64, 81, right, on up, 100. That has to be a perfect square. The front number must also be a perfect square, okay? For those two things, if those two things happen, this could be what's called a perfect square trinomial. Basically one that factors into something like this. Now, do you have to know those tricks? No, you don't need to know those tricks. You could just factor it like normal. But some of them just get a little bit more difficult. Like this one. Now, first off, is there a GCF? What's the only number that 9 is divisible by? 3 and 9, right? Okay, is 15 divisible by 9? No, so I'm limited down to 3, right? 15 is still divisible by 3. Is 64 divisible by 3? No. So does this have a GCF? No. Okay, so I continue down my flow chart. It's got 3 terms. Is this an easy type or hard type? Okay, so now I have to do what? 9 times 64, right? Ooh. What is that? 576. Okay, now my mind is going to go to this. What's unique about 9 and 64? Look at our first number and our last number. Those two numbers that I just multiplied by. What are unique about those numbers? They're both perfect squares. 9 is a perfect square. 64 is a perfect square. Okay, so this might actually be another perfect square. What do I mean by that? What happens if I square root 576? 24. Right? 24. I get something that is also another perfect square. 24 times 24. Now, what does my middle number have to get to? Negative 15, right? So what are my two last numbers both going to have to be? They're both going to have to be what? Negative, right? So I would have to say, now, does negative 24 times negative 24 work? No. So this is not one of those ones where it factors into the same thing squared. Okay? It's not. It's not going to work like that. Okay? So I would continue on the rest of my list now. Right? I would have to say, okay, would 1 times 576 work? No. What about, okay, 576 divided by 2? Well, that's not going to work. Oops. Is that going to work? No. Is that going to work? No. I mean, my number, that would be negative 148, right? That's not going to work. Okay, the thing is, if I keep getting small, 5's not divisible by 6, nope, that's not going to work. I keep getting smaller and smaller. I wonder if 7 works. Nope. Nope. I'm getting smaller and smaller, but the closer I get up to maybe 22. No. See, look at these numbers. The smallest total possible I'm going to get is the one that's on the board there. Negative 24 and negative 24. It could only ever get as small as negative 48. Negative 48. So what do I say about this one? Okay? I could make out this entire list, but I know that none of them are going to end up equaling negative 15. Everybody look up at the homework board real quick. I am going to, everybody look up at the homework board real quick. I am going to tell you how many are not factorable, okay? So you just can't go to your homework and write all of them are not factorable and say, I did my homework, right? You're only allowed to use that answer 4 times, no more than that, okay? Only 4 are not factorable on the entire homework. Deal? Okay. Let's do this one now. A huge number, right?
Let's go.
What is 81 times 25?
2025.
2025? Okay, now, what do I notice about 81 and 25? They're both perfect squares, right? They're both perfect squares. So here's what I'm going to say. Why don't you guys square root 2025? What do you get when you square root 2025? Is that also a perfect square? 45. Is that it? It is. So this is one of those special cases. This works because 45 plus 45 gets us 90. Now I can go through and do my factoring by grouping. Now my GCFs are going to be big, but that's okay. 81x squared plus 45x plus 45x plus 25. Okay, what's my GCF of my first 2 terms? What's my GCF of my first 2 terms? What do we think? No? 9x, good. 9x. Okay, well that means I leave a 9x, right? Because I divide out a 9. 81 divided by 9 is 9. Plus 5. Okay, what's my GCF out of my second part? 5, right? Just a 5. No x, just a 5. Leaving a 9x plus 5. What do I pull out? 9x plus 5. What are my leftovers? 9x plus 5. Look at this. You want to see something that's going to blow your mind? What's the square root of 81? What's the square root of 25? That's 9x plus 5 squared. So, see, I know this shortcut, and I know I've learned this before because I teach math and I use it all the time, right? If you need to fall back on factoring this, by all means, we just showed it that it works, right? But if you get a perfect square here and they add up to the middle number, guess what you can just do? Square root, squared. You see that? I know when it sets up like this, it's called a perfect square trinomial. You can take the square root of the first and square root of the last, and you put it as your 2 terms. Okay. But again, that's just a trick. That's just a trick. Only special cases. All right. Now we're going to talk about how we factor something with 2 terms. Okay. Think back in chapter 7. Think way back in chapter 7. We talked about those products that when we multiplied them, the inners and the outers canceled out so that we were just left with 2 terms, right? We were just left with like x squared minus 64 or something like that, right? Now, again, in chapter 8, we're working backward. We're unmultiplying. We're factoring, right? So this is what's called a difference of squares. The difference of squares. And you have it on your page, right? Your difference of squares. Okay, let me show the definition here. Now, these 2 things must be true for it to be a difference of squares. The first thing, they have to be a difference. It says it right there in the name. They must be a difference. What happens if it's a plus sign? If there's no GCF, then it's not factorable. Both terms must be perfect squares. We just talked about them. What are perfect squares? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. If you keep going, that's okay though. It's just up to 15. Also, perfect squares with variables in them, right? X squared is a perfect square. X to the fourth is a perfect square. X to the sixth is a perfect square. X to the eighth is a perfect square. What's the pattern there? Right? Any power that's divisible by 2 is a perfect square. Right? That's a perfect square. Any power that's divisible by 2. Okay? Now, what do we do with them? Right? Now we know how to identify them, but what do we do with them? If it is a difference of squares, then you square root each one and put a minus and a plus. Okay? You square root each one and put a minus and a plus. So, take a look at the algebra here. I've got a squared and b squared. Both perfect squares, right? Both even powers. Now, is there a minus sign in between them? So I can confirm, yes, this is a difference of squares. So what do we do with it? We square root a, write it as our first terms. We square root b, write it as our second terms. And then just put a plus or minus in between each one. That's it. Okay? Does order matter? Do I need to put the minus before the plus? No. Right? Order doesn't matter in these. Okay? So let's try one. Flip it over to the back, please. So now I can add this to our list here. Difference of squares. Okay. First thing, is there any GCF? I should start at the top of my flow chart. Is there any GCF? No. How many terms do you see? Is this a difference of squares? Let's check. First off, is it a difference?
Yeah.
Yes, it is. This is a minus sign. Is that a perfect square? Yes. How do I know? Because the power is divisible by 2, right? X to the second power. Is 25 a perfect square? Yes. Is y squared a perfect square? Yes. So this is a difference of squares. So what does that mean? That this factors into two pieces, one with a minus, one with a plus. Okay. What happens if I square root x squared? What do I get? Just x, right? What's the square root of 25y squared? Just 5y, right? 5y, 5y. The reason one is a minus and one is a plus is because the inner, like if I were to FOIL this back out, the inners and outers have to cancel. They must cancel with each other. So therefore, one's going to be a minus and one's going to be a plus. All right. You may be thinking to yourself, okay, 3 is not a perfect square. I'm done. Not factorable. There's one of my 4. Sure. What did I forget? GCF. What's my GCF? 3. So we remove it. What's left over? What's left over? P to the second minus what? 3q to the 4th. Okay, now, is p squared a perfect square? Is this a minus sign? Is 3q to the 4th a perfect square? No. Is q to the 4th good? Yes, but is 3 a perfect square? No. So I wouldn't write not factorable because we did something to it, right? We removed the 3. So that's just my answer. Okay, let's try our next one here. Okay. What do I check first? Does this have a GCF? Yes. What is it? 4. See, I bet a lot of you guys started saying, ooh, 100 is 10 squared, and 4 is 2 squared, right? Yeah, don't go with the flow chart. GCF first. Okay, so if I pull out a 4, what's left over? 25x squared minus y squared. So now we check. Okay, so I'm done factoring out my GCF. It's 2 terms, so I go here. Okay, is this a difference of squares? First off, is it a difference? Is this a subtraction sign? Yes. Are they both perfect squares? Is 25 a perfect square? Is x squared a perfect square? Is y squared a perfect square? So yes, this is indeed a difference of squares. So that means don't forget about your 4. The 4 stays out front. And now I get 2 parentheses, one with a minus and one with a plus. And I square root each one. 5x and y. Questions about that? Yeah, let's keep it rolling. Okay, so is there any GCF here? I'm taking my flow chart. Any GCF other than 1? No. There's no GCF other than 1. So I can't pull anything out. So now I say, okay, I'm done checking for a GCF. Now I go down here. Is this a difference, first off? Yes. Are these perfect squares? Is p to the 8th perfect square? Yeah, how do I know? The power is divisible by 2. Is 49 a perfect square? Yes. That's 7 squared. Is q to the 6th a perfect square? Yes. So this is a difference of squares. So how do we write that then? Okay. Well, there's a minus and a plus, right? Okay, what's the square root of p to the 8th? Anybody have an idea? What's the square root of p to the 8th? What do we think? Noah? P to the 4th. Yeah. Okay, what's the square root of 49? 7. Now, what should the power on q be? 3. Yeah. If it's divisible by, see, the rule was, the check was if the power is divisible by 2, well, then just divide it by 2. That make sense? Okay. Okay, let's try this next one here. Go ahead and try that one. Who else we missing right there? I'm like, who you missing? Okay. Did we all check for a GCF?
Yes.
Good. All right, so 4 comes out and left with a 4x squared minus y to the 5th. Okay, good. So this is a difference. Our first term, 4x squared. Is that a perfect square? Y to the 5th. Is that a perfect square? No. Bummer. That's all I can do.
It's money in the bank. What's money in the bank? I got it.
Okay, let's keep it going. Last one here on this set.
That's when somebody has that food.
That's so awful.
That is kind of awkward. It's like how Piggy Grandma has her house phone and like when it rains, it's like a tornado belt.
So is there any GCF? No. Okay, now I have to see, is this a difference of squares? Is 121 a perfect square? Yes, it is. How do I check that? Well, just take the square root of 121 and see if it comes out as a whole number. It's 11. Is x squared a perfect square? Is this a difference? Is 4 a perfect square? Is y to the 8th a perfect square? So this is a difference of squares. One with a minus, one with a plus. Okay, we just saw square root of 121 is 11. So it's 11x. And then my second term, what's the square root of 4? So it's 2y to the what power? 4th power. Feel okay about that? So now you know how to factor something with 2 terms, 3 terms, or 4 terms. We've done all the factoring that we possibly can. So now let's mix it up. The directions are just to factor. And I'll tell you this, guys, that's the next section as well. Honestly, it's just, the directions just say factor. And you have to decide what to do. Okay, flowchart says do what first? Is there a GCF? What is it? So let's remove it. What's left over after I factor out the 3? X squared minus 4x plus 4. Okay. What are the factors of positive 4 that add to get to negative 4? What are they? Negative 2, negative 2. Is this an easy type or a hard type with this 3 term? Easy type, because I removed that 3, didn't I? Look at just in between the parentheses. That's an easy type. So I can say that this is 3, x minus 2, x minus 2. That would be a completely fine answer. How else could I have written that? Stuck up on me like I'm a ninja, man.
Is Ninja Chair still blue?
Whose phone is that?
Yours.
Uh-oh, that's my wife. I gotta take that.
Uh-oh.
He's in trouble.
Hi, honey.
What'd you do, Miss Flagler?
You forgot to lock the door.
Put on speaker.
Oh, my wife has a math question.
Whoa.
What? During class? She must be in class too. Okay. Go ahead.
Ask her if you're on speakerphone.
That's okay. What's up? Okay. Oh, jeez.
Yeah. Oh, that's
I missed the collaborative class. How are you guys doing today?
Good.
I could see both ways, but honestly, I would put credit on the positive side and debit on the negative side.
I don't know.
Okay. I'm glad I'm on your side. They didn't hear the question.
I wonder why they
Should
didn't want
I
to
have
on
the- okay, hold
speakerphone.
on, I gotta put them on speakerphone too now.
Hello?
Okay, so they're doing an activity where they're putting words on a number line in terms of positive or negative, right? So they have the words credit and debit, okay? So where would you put credit and debit on a number line? Would credit go on the positive side or the negative side?
Negative,
I don't know
because you have the
Because
money.
you think about credit card, taking money out, I could see the negative.
Because you have the money.
But, or
you
if
have
I
the money.
give you credit,
You're getting.
I'm giving you money, right? Like I'm
Do
giving
hang
you.
up on her?
No, a debit card definitely goes on the y-axis.
That makes no sense.
Wait,
All right,
what's
I'm back.
next?
They had no idea what I was talking about. Somebody said credit goes on the y-axis.
Hey.
Yeah, I meant it as debt instead of debit. Yeah, because I would say debt goes on the negative.
Ty, no one just stabbed me in the face.
Okay.
Well, I would have felt horrible, Jack.
Thank you for helping them out.
You would have to attend that. You do anything to them?
No, I don't think so. One time she Skyped me in the middle of class, like last year, because they were, she bet her students that she could beat me in like a flashcard race or something, so we did it on through Skype.
Power
Power couple right there. That's
Hashtag
right.
relationship.
Okay, try this one. Try this one.
That was funny.
That was kind of funny. I'll give you this.
We can do it the whole globetrotters.
Just so you guys know, oh man, that was all recorded.
Yeah.
That's really funny. Just so you guys know, the this little cubby down here is for anything that I find in class, like at the end of a period. So if you misplaced something, that stuff has been down there for a long time.
It's all mine.
It's a nice Superman water bottle.
Yeah, that can be.
That's
Aereo? What's Aereo?
Arrow.
Oh, Arrow. Aereo.
Hey, my boy was a witness.
It does
It was a crime.
It's a shaker.
It's Superman!
What's stuff in it? That is disgusting. That needs washed.
It's a shaker.
Oh, that stinks. Sorry.
Hey, that was probably a 2-pointer, but.
Ew.
That's dumb. I shook that and I smelled it.
That's disgusting.
Back to math. Okay, be honest, who did 16 times 36?
I did it first.
No, just.
Oh, wait, no.
There's a GCF in this, isn't there?
Yes.
Yeah. What is my GCF? 4x.
Whoa.
Okay. So what do I have to do? Right, I've done my GCF, now I go 3 terms. Is this an easy type or hard type? Bummer, dude. 4 times 9 is 36. Okay, now, I'm recognizing this. Is 4 a perfect square? Is 9 a perfect square? Okay. 36. What happens if I square root 36? What do I get? Is that my factor? So my shortcut says, oops, sorry. If you worked it out the hard way, that's completely fine. But if 4x is a perfect square, and 9x is a perfect, and 9 is a perfect square, and 36 got us 6 and 6 to make 12, I know that that factors into 2x plus 3 squared. If you did the hard type factoring, that would be completely fine too. It should have worked out the same way. Last problem that we have here is 9x squared a perfect square? Is 144y to the 4th a perfect square? Is this a difference? Yes. So I know that this is a difference of squares. This is a 3x. This is a 12y squared. Oh, shoot.
Oh, right.
Oh, there was a GCF. Oh, Mr. Laverick. Oh, man, I'm going to have to re-record this lesson.
Oh man, I wrote
This is bad.
All of this is a blooper.
Blooper reel.
I bet you it'll get the most views.
Is 144 just one of 9?
Let's hope not.
No, it's
Yes.
12.
What?
Oh, my.
That's literally what I am.
Yikes.
Whoa.
Whoa.
Yeah,
So now, this turns into 9x minus 4y squared x plus 4y squared. Okay? Because you have the square root of x squared is just x. The square root of 16y to the 4th is 4y squared. 1 minus, 1 plus. All right. We'll see if I actually use this recording.
You can have it. I'll watch it.